This title tells us we're focusing on how the new parameter affects the SGDOneClassSVM algorithm. That algorithm is used for detecting outliers in a dataset, those unusual data points that don't fit the norm. The new parameter is the star of the show here. I'll explain what it does. This is a quiz question. We are using the SGDOneClassSVM function from the Sklearn library in Python to find outliers. It's set up with a new value of 0.1. The quiz will test my understanding of how the new parameter influences the algorithm's performance. I understand this. A higher new means the model anticipates more outliers. It's like setting a wider net. Therefore, a larger fraction of data points will be labeled as outliers. This statement is correct. A lower new is like using a fine-toothed comb. The model expects fewer outliers. It's more discerning and demands stronger evidence before classifying something as an outlier. It's stricter because the model is more conservative. Let's check if this is true. Support vectors define the model's decision boundary. A higher new indicates a greater tolerance for errors and more data points classified as inliers. In other words, it should have more support vectors, not fewer. So, I am marking this as false. The margin is the gap between classes in a classification model. With a higher new, the model accepts more errors. Consequently, the margin may become smaller to accommodate more data points as inliers. The statement is incorrect. I'm explaining the impact of the new parameter in the support vector machine algorithm called SGDOneClassSVM, which is used for outlier detection. It's all about understanding how this parameter influences the model's behavior. Let's dive in. A smaller new value tells the SGDOneClassSVM that you expect very few outliers in your data. Therefore, the model will set a high bar for identifying a data point as an outlier, resulting in a stricter detection process. Think of it like this. A smaller new is like having a really tight net. Only the most unusual fish, outliers, will get caught. Pretty cool, huh? With a larger new, you're telling the SGDOneClassSVM that you anticipate a significant portion of your data to be outliers. As a result, the model becomes more lenient in classifying data points as outliers. It's like using a wide net. You'll catch a much larger portion of fish, some of which might not be particularly unusual. Makes sense, right? I'll explain the NU parameter in SGDOneClassSVM. It's a crucial parameter that controls the model's behavior in detecting outliers. Think of it as a knob that you can adjust to change the model's sensitivity. A smaller NU value means the model expects fewer outliers and will be more strict in its classification. Conversely, a larger NU value means the model expects more outliers and will be more lenient. This question is about the NU parameter in the SGDOneClassSVM model. Specifically how changing NU affects how well the model identifies outliers. I disagree. Increasing NU will likely result in a smaller margin, because the model will tolerate more errors and include more data points as inliers. Nope. A larger NU implies a larger number of support vectors. You'll need more support vectors to accommodate more inliers when you're increasing the tolerance for errors. That's correct. A smaller NU means the model expects fewer outliers, so it will be stricter in classifying data points as outliers. This is accurate. A larger NU indicates that the model expects more outliers in the data, leading to a larger proportion of points being classified as such. I'm focusing on how the new parameter in the SGDOneClassSVM algorithm affects outlier detection. This parameter is key to understanding the model's behavior. We're using the SGDOneClassSVM, stochastic gradient descent one-class support vector machine, from the Sklearn library to find outliers. The NU parameter, set to 0.1, is the star of the show. Imagine a smaller NU value. I interpret this as a higher bar for identifying outliers. The model becomes more conservative. Only extreme data points will be flagged. This is like setting a higher threshold for what counts as an anomaly. With a larger NU, I expect the model to label a bigger chunk of data points as outliers. Think of it as lowering the bar, making it easier to identify anything that's slightly out of the ordinary as an outlier. the model becomes less strict in its judgment. I see the term new parameter in SGDOneClassSVM. It's a crucial setting that controls how many data points the model expects to be outliers. Think of it like this: a smaller new means I'm expecting very few outliers, so I'll set a stricter threshold for identifying them. Conversely, a larger new means I'm expecting more outliers, so the threshold is more lenient. It's also related to how many SUPPORTVECTORs the model will have. These support vectors define the boundary between inliers and outliers. I'm focusing on the effect of a small new value. A smaller new means you're telling the model that you expect only a tiny fraction of the data points to be outliers. Because of this, the model will use a stricter threshold. It will only classify as an outlier a data point that is quite distant from the cluster of normal data points, making the outlier detection stricter. Now, let's look at the impact of a larger new. A large new value means you're telling the model you anticipate many outliers. As a result, the model becomes more tolerant and will classify a larger chunk of data points as outliers. The threshold for outlier classification is lowered. Increasing new means you are expecting more outliers. This, in turn, results in a less precise boundary between inliers and outliers. The model might have fewer support vectors as it is accommodating more outliers within the boundary. If I increase new, I'm telling the model to expect more outliers. Therefore, the margin, the space around the support vectors, is likely to become smaller because the model needs to include more points in the inlier category. This makes the statement false. I see that NU is a crucial parameter in the SGDOneClassSVM algorithm. It acts like a control knob, setting both an upper limit on the number of training errors and a lower limit on the number of support vectors that the model uses. Think of it as setting a limit for how many data points the algorithm can misclassify as not outliers, and a lower limit on how many points form the boundary. This directly affects how sensitive the model is to outliers. A higher NU means you are telling the model you expect more outliers. I'm focusing on this line. SGDOneClassSVM uses NU to limit the number of data points it can wrongly classify and the number of points needed to define the boundary between outliers and inliers. A higher NU allows more errors, higher upper bound, and will use more support vectors to define a more complex boundary, higher lower bound. It's about balancing how many mistakes you allow versus how complex you let your decision boundary be. This emphasizes that NU directly influences how much the model pays attention to unusual data points. A small NU value makes the model very picky about outliers, and vice versa. It's like adjusting the sensitivity of a metal detector. A higher sensitivity, higher NU, will detect more signals, outliers, even small ones that might be noise. This title tells us that we'll be learning about how the new parameter affects the performance of the one-class support vector machine algorithm from the Sklearn library, SGDOneClassSVM. It's a crucial parameter that controls how the model identifies outliers. Get ready to become an expert. This sets the stage for the quiz. I'm using a specific algorithm, SGDOneClassSVM, stochastic gradient descent one-class support vector machine, to find outliers in a dataset. The "new" parameter is key here. It influences how many points the model classifies as outliers. Let's figure out how. If you set a smaller "new", you're telling the model that you expect very few outliers in the data. The model will then apply stricter rules to decide what it considers an outlier, meaning only the most unusual data points get flagged. I am setting a larger "new" value. I am telling the model that I expect more outliers. This makes the model more lenient. More data points are now labeled as outliers because the threshold for being an outlier is lower. This is the heart of the problem. The "new" parameter in SGDOneClassSVM is a control knob. It directly affects how many data points the model labels as outliers and how the model builds its decision boundary. Understanding this parameter is key. This reminds us that we're working with data, a collection of observations which the algorithm processes. The algorithm analyzes the data to spot outliers, points significantly different from the rest. This highlights the goal. We're looking to get insights on the outliers detected by the model and how the "new" parameter affects those results. The results directly depend on the "new" value we choose.